All right. So thanks for joining us today. I'll be telling you a little bit about how to use the roof savings calculator. First, a little bit about me. I'm Joshua New. I'm a PhD in computer science from the University of Tennessee. I've been full-time staff here at Oak Ridge National Lab for 7 years, and this was actually one of the first projects I became involved with before becoming subprogram manager for software tools and models in the Building Technology Research and Integration Center. That involves projects from websites, web services, databases, supercomputing, artificial intelligence, computer vision, and supercomputing for deep learning. So let me get into the roof savings calculator. First, let me start with a little context. Most people are surprised to find out that buildings consume about 41% of the primary energy in the U.S., split roughly between 4.9 million commercial buildings and 114 million residential buildings. In fact, if we look at the energy use for residential and commercial separately, we can see generally heating and cooling our homes is about half the total energy use for our buildings, with the rest made up from water heating, lighting, and then several other use cases and miscellaneous plug loads. One of the challenges we have in making our U.S. building stock more energy efficient is that the average homeowner only spends about $1,800 a year. So anything that we do to save energy can only save some fraction of that amount, and it usually has to pay itself off in the 6 to 7 years a person typically owns a home for it to be cost effective. So that's a big challenge. In the commercial space, we have a little bit more advantage because commercial buildings are typically larger, they use more energy, and so there are things that are more cost effective for commercial buildings. Well, if you look at all that energy use, there's concomitant greenhouse gas emissions. If you don't count nuclear, about 8% of our energy provided in the U.S. is from renewable sources. And in fact, there are future challenges as coal and gas and other petroleum sources are expected to diminish over time. As photovoltaics continues to increase, it becomes an energy security challenge to provide a high quality of life and a high energy consumption for all the people around the globe while maintaining the quality of life that we currently enjoy in the United States. In order to address that, we have to look at every possible technology we can as to how to save energy in buildings. Right now, there's something called the Roof Savings Calculator that I'll be talking to you about today. What is the Roof Savings Calculator? Well, it's a website and a web service. So if you go to roofcalc.com, roof as in calculator, roofcalc.com, then you can put in details about your building and kind of have this is my current home, this is what I'd like to do to my home. Hit calculate and it'll tell you about how much energy and how much money you would save in doing that thing to your home. There's also a web service, so people that are familiar with APIs that don't want to manually click buttons on a website but want to process files and software, send it to our simulation servers and get the results and use those. There's also a very easy to use web service using standard technologies. So a little bit about the backstory of how Roof Savings Calculator came to be. It was a large collaboration among several people, the Department of Energy's Building Technologies Program and Office, Chris Scruton from the California Energy Commission, several national labs, Lawrence Berkeley National Lab, Oak Ridge National Lab, some subcontractors and industry partners all work together to make the Roof Savings Calculator happen. Well, one of the reasons that the Roof Savings Calculator existed as a project is that there were two main calculators, one from the Environmental Protection Agency, EPA, and the Department of Energy. The problem is that for the same technology, they could be off by an order of magnitude. Do you save $50 a year or $500 a year? It was really uncertain. So to create an industry consensus standard that people could have faith in the estimates provided for energy savings, we developed the Roof Savings Calculator. One of the things we wanted to do is not lose any of the functionality of the other two calculators. And there was a project advisory committee that had different reports and slides that said, we really would like the calculator to do these things. So the Roof Savings Calculator here captures almost all of the functions of the previous calculators, as well as the things that the committee would like to have added. We also had a challenge in making this usable. So, when you define a simulation of a building, there are literally thousands of parameters that you could use to define the building. Occupancy schedules, how people behave in the building, the material properties of each layer in a wall. But what we wanted to do is make it very simple. So we came up with 20 kind of most important questions that most people would know about their building in order to make it easy to put in data into this calculator. We also use very intelligent defaults. So we have good surveys across the entire U.S. building stock. So we know how Joe, the average American, behaves in his building, and we use that kind of schedule, whether he's in an office or at home, there's different things that he does. So we try to default everything to a national average so that the only thing you have to know to run the calculator is where you're located, what city and state. Most people know that information. So what is the roof savings calculator? Under the hood, it's two simulation engines. One's called DOE21E, which is a whole building simulation package, and then AtticSim, which does high fidelity physics simulations of what goes on in a roof and attic assembly. Here you actually see the conduction, convection, and radiation at every surface that AtticSim is calculating. In fact, AtticSim is part of a standard called ASTM C1340. As part of a standard, it goes through a thorough vetting process, lots of review by industry, and before it's accepted as a standard. What we've done is we've tied this high fidelity physics simulation of the roof and attic to a whole building so that we know if you add insulation or change your roof, how much energy you would save in heating and cooling your home. So it's been used fairly prevalently, 64 visitors per day since 2010. It's very popular in hot states that are interested in cool roofing like California, Texas, and Florida. And if you go to roofcalc.com, you should see a website that looks like this. What does it do? It allows you to put in your building details, your HVAC efficiency and utility pricing, and then you can do a base versus comparison. So if I have this much insulation and I add more insulation to my home, how much energy do I save? You go to this website and you can click on residential or commercial for whichever building type you're most interested in. The residential building is modeled like this, a pretty typical home layout. And in the commercial space, we support three building types: the medium office, which is where most people work, big box retail, where most people shop, and then a warehouse where we store our goods that are shipped before they go to the go to where we can buy them. So these are the three commercial building types that are currently supported. And once you go to the website and click on those buildings, this is what you should see. This is basically the input page and the description of the output. So here you have details about your building, your heating and cooling system, then you have your current home, your more energy efficient home where you add insulation or get a more reflective roof. Once you hit calculate, we send all this input data you provide to our calculation simulation engine. It runs for about 2 minutes on average, and then we output data and roll that up into how much dollars a year you would save. That's what most people care about. So let me go into each of these in detail. So when you go to the building information, you can have either a residential or a commercial building. You put in the location, which is required. Everything else is defaulted, but if you have more accurate information, then our estimates will be more accurate. You can put in your building type, condition floor area in terms of square footage, number of floors, the window to wall ratio. Most people don't know this, but commercial buildings are 40% window to wall ratio, and residential is 14.5%. That's how much of the surface area of a wall is window versus brick or whatever other material you're using. And then year of construction. That's an important thing because building codes continuously get more energy efficient. So based on this year, we have kind of prototypical buildings, built to code buildings for that time period, of which we layer with additional information as you provide. Most people, one of the interesting things is these little question marks here. If there's something you don't know, you can click here to get more information. A geek like me is really interested in, what's the floor area of U.S. buildings on average, median, and mean? Well, you actually have that from 1973 onward, and you can tell for different areas in the U.S. kind of what the average home is. They're typically around 2,500 square feet now, and they've been getting pretty much progressively bigger over time. Interesting things. Also, on the heating and cooling side, so do you have a heat pump or a natural gas furnace? Most people have a natural gas furnace. We also load it with electricity and natural gas prices. But just like with the question marks, you could click those and see kind of how prices just change over time and get the actual utility prices for your area. Most people don't know how many cents per kilowatt hour they pay until they look that kind of information up. And then we have the heating and cooling efficiency of your HVAC unit. And we default these to what's average for that code of building, but you can certainly change that or look up other information if you, these links actually tell you where to get information off your unit and how to convert it to these units if it's not already in that unit. So Once you put in the building and HVAC details, then we get into the core of the simulation comparison, which is, here's my roof and attic system, and what can I do to make it more energy efficient? So let me go through each of those details. About 90% of homes have asphalt shingles on their roof. You can see this picture, and most people identify that's what's on my roof. But you can also have metal or tile roofs. We're actually simulating the turbulent airflow over these different profile tiles, so very high fidelity physics in these calculations. Also in the commercial roof type, built-up roof is probably the most popular, but there's also a lot of metal, concrete pavers, single-ply membranes, other roof types and materials that we simulate the thermal mass and the thermal conductance, specific heat, emittance, and reflectivity of all these surfaces. Once you select a material, we have a default reflectance, but you can change that. And what we ask is that you use an aged 3-year value, because most products like a white roof will be very reflective at first, but in 3 years it kind of drops down and hits the asymptote of where the real reflectivity of that roof is. And if you don't happen to know that, you can actually go to this Cool Roof Rating Council. You just mouse over the question. You can click that link and actually look up specific products to get the aged reflectance values for your material. Also, the outside layer, the roof layer, not only has a reflectance, which is how much of the sun gets reflected, but also a thermal emittance. As it heats up, it emits long wave radiation. And so over 90% of materials, or 90%, have an emittance of 90%. But if you have a metal roof or a special type of coated roof, then you can get a lower reflectance, which is actually a little more energy efficient. I should say that these questions are always ordered from least energy efficient at the bottom to most energy efficient at the top. So you can generally find out what is a more energy efficient option for each of these questions. Then we have roof pitch. The average residential building is a slope of 4 rise, 12 run, 4 and 12. But you can change it if you have a tall A-frame type house or a relatively flat roof. In the commercial building space, a low or a flat roof is actually 1/4 and 12 because we need a little runoff for water. Then there's something called above sheathing ventilation. This is something that's not popular today, but it's growing in popularity. It's called above sheathing ventilation, but it's also known as a roof on a roof, which is more descriptive to someone that is unfamiliar with this. The idea is if you have like a hailstorm come through the area and damages your roof, but it's not leaking, instead of tearing off all that material and throwing it in a landfill, you can actually just lay down a double counterbattens or another system on top of it and put another roof on top. You save yourself disposing of all that material, filling up our landfills, plus you have extra barriers between the incoming heat of the sun and the performance of the building. So it's another layer of encapsulation for the conditioned building. We also model radiant barriers. So a lot of people think of it as tinfoil with a reflective side facing outward. And what you do is you can drape this on the rafters, is how we model it. And as it heats up, what it does is it keeps the heat from being transmitted into the roof and attic assembly. So it's another barrier there's 3 ways heat is transferred: conduction, convection, and radiation. And so radiant barriers help cut down the radiation component. It's one of the few technologies for doing that. Also, I think most people are familiar with attic insulation. So if you have, we just look at the R value. So whether it's loose fill blown or, a fiberglass bat, if you know the R value, you can say, okay, this is my current R value of insulation. If I pay someone to come add insulation to my home, then I can change that to a higher value. Also, duct location. Even though it's generally the worst place to put them, we always put ducts in the attic because it's time efficient from a construction standpoint. The problem is that you have leakage and you cool the air and you're putting it through these ducts, but your attic can be sweltering hot in the southern climates. And so all that leakage, all that heat is just zapping all that energy you put into creating that cool air in the first place. So we have ducts in the attic as the default, but we can also have ducts in the conditioned space. So if you have a basement where the ducts go through or a crawl space, that's generally a little more energy efficient perspective, because if you have duct leakage, it's actually going to cool the space rather than cooling the outdoors. An interesting thing too is that ducts are leaky. So the average uninspected duct is 14% leaky, and an inspected duct is 4% leaky. Most people haven't inspected or sealed their ducts. And so we saw earlier the average homeowner uses 54% of their energy for heating and cooling their home. And if it's 14% leaky, that means 7% of your utility bill is going to heat and cool the outdoors, not your home. So duct leakage is a major input, a major parameter that affects energy usage. If you want to make your home more energy efficient, sealing your ducts is usually one of the top recommendations. And with that, I'd like to, so I showed you the website, and I just want to show briefly talk briefly about the web service. There's a link here that gives you a step-by-step process on how to use the web service. I did it myself. It took about 8 minutes for me to install all the packages and set everything up. So it's a relatively quick process to get started. Again, step-by-step instructions are there at that link. And so I don't have time today to talk about all the different large-scale displays and, we've run over 3 million simulations. We've done analysis. We have lots of reports about what's good and bad about the calculator. But if you go to roofcalc.com, you can use the website and web service as I've described. And what's interesting is that a lot of companies are now using it to upsell their customers. So if you're a company that sells or manufactures or distributes roofing or attic products, what companies are doing now is they have a quotation system. So a customer comes to them and says, hey, I'm interested in, I need to get a new roof, or I want to make my home more energy efficient. Well, they give them an option of like 10 different products, and here's the prices for each of those products. The problem is they have no way of saying, if you paid a little more premium for this energy saving technology, we could save you this many dollars a year. It would pay for itself in 3 years, and then you'd be putting money in the bank. And so companies are using this as a third-party service where they take their quotation system, use the web service to send that to our simulation engine, get back the results, and then put it in the quotation system and say, here's our kind of default offerings, and then here's some more energy efficient offerings that could save you money in the long run. I call that a triple win because the customer gets a better product, the company gets to upsell their clients, and the Department of Energy gets energy-saving technologies into the marketplace. And if you want more information, we'll put a link in the description of the video to this presentation. The last slide here contains a lot of links for publications and presentations. I would probably point you to this How to Use DOE's Roof Savings Calculator. It gives a lot more step-by-step information about how to use the website and web servicing if you're interested. Thank you for spending time with me today, and I hope you find the Roof Savings Calculator useful.